the limitations of the first law of thermodynamics. And I told you that the note that I have already sent to you, from there you can read and write it. Now, so we are going for the second law of thermodynamics. So second law of thermodynamics deals with the spontaneity of a process. First law deals with the relationship between the work and the heat. And second law of thermodynamics deals with the spontaneity of a process. That why does the process occurs? Whether it's a physical process or chemical process, why does it occurs? Okay. So I briefly told you yesterday also that there are two reasons for which a process becomes spontaneous, which means spontaneous means what? Which occurs by itself. That is, it has an urge or liking to occur. So there we have found there are two reasons for which a process can occur. One is to attain maximum freedom or randomness. And the second is the decrease in the free energy of a process. All right. And so in whichever way this can be achieved, so they will follow that path. So now I'm going to write the second law of thermodynamics. It is very interesting. Your book has dealt with the second law of thermodynamics, but nowhere the second law is written. First law, they have given the definition. They have discussed about the spontaneity of a process, decrease in free energy, but nowhere they have mentioned anything about the second law. So let us write the second law of thermodynamics. So as the first law, we can, different way we have written the first law. So similarly, the second law also can be written in the similar way. Second law of thermodynamics. It can be defined by the following expressions. Okay. We'll write now here. All spontaneous processes are thermodynamically irreversible. Irreversible. That is, if a river originates from a mountain, that is the water from the higher altitude goes to the lower altitude, you cannot reverse the process. You can't force the sea to send back the water to the mountain from where it came. Okay. Second. Whenever a spontaneous process takes place, it is accompanied by an increase in the total energy of the universe. That is system and surroundings. Third, it is impossible to convert heat completely into equivalent amount of work without producing changes elsewhere. Right. Thermodynamics. So now I'm going to introduce a new term called entropy. See, entropy means disorderness, randomness, disturbance. Okay? It is a thermodynamic state quantity which is a measure of randomness or disorder of the molecules of the system. It is represented by, just a minute, huh? Just a minute. This symbol, S. Now I'm writing something. You will not write. See here. All the particles are now closely packed. They cannot move. Now, when it gradually turns into liquid, what happens? In this case, you will find a gap is being created between them. Now they can move. That is, their disorder has increased. Here they are just like soldiers. They are only in their position. They are not moving. Okay? Now, suppose these are march past. They can walk, but they cannot run. They cannot go in any direction. Now, when it goes to the vapor state, see, it can go anywhere. In the whole room, it can travel. Any of the room, it can travel. It can go outside also. It can travel. So in this case, what has happened? The freedom is increased. That is, the randomness is increased. It is entropy is increasing. Okay. See, in our society, if any crime is being done, the person is being put into jail. Why? That is, we steal his freedom. That is, we decrease his entropy, and it is a very, very painful thing. Okay. Now, entropy change. Entropy change. Entropy is a state quantity. So entropy change is what? If you subtract from initial from final, then that is the entropy. It is difficult to define the actual change in entropy. It is more convenient to define change in entropy during a change of state. Just now I showed you that from crystal it has become liquid, from liquid it has become vapor. Change of state. The change in entropy from initial to final state of a system is represented by delta S. The entropy, I told you entropy is a state function. The entropy is a state function. And depends only on the initial and final states of the system. Therefore, delta S is equal to S final minus S initial. For a chemical reaction, delta S is S products minus S reactants. During a process, also be maybe defined as the amount of heat absorbed isothermally and reversibly. Divided by the absolute temperature at which the heat is absorbed. For a reversible process at equilibrium, the change of entropy may be expressed as delta S equal to Q reversible. This Q means heat divided by T. See, if the heat is absorbed, then the entropy increases. And if the heat is given out, then the entropy decreases. If heat is absorbed, delta S is positive. What does it mean? Entropy increases. That you have seen, na? During winter, when you don't get up from the bed, then you suddenly will find some of you in your house start shouting, then immediately you get up. Entropy increases. That is, heat is being supplied to you. And if heat is evolved, delta S is negative. Decrease in entropy. several factors influence the amount of entropy that a system has in a particular state. 1. The value of entropy depends on the mass of the system. See, if the volume of air in certain area is very high, it leads to storm. Storm means what? Huge disturbance. Entropy is very high. If it is very low, then you do not even feel the presence of air around you. Okay? The movement will be very slow. If the volume of water in a place becomes enormous, then it leads to flood. It washes everything around it. Okay? But look at a small pond. In that case, you'll find the water is calm, quiet, and still. Is it not? So, what does it mean? Entropy is an extensive property. I told you that two types of state properties are there. One which depends upon the amount of substance, and one which is indifferent of the amount of substance. All right? Like if you want to boil more amount of water, you have to heat it for more time. So it is an extensive property. But irrespective of the volume of water, boiling point of water is always 100 degrees Celsius. So it is independent of the amount of the water. So this is called intensive property. So what we can say here now? Thus, it is an extensive property. Second, see here. It depends on the state of the system. It depends on the state of the system. I told you also. A liquid has more entropy than solids. Why? Because liquid can move. In solid, particles cannot move. In a solid, the atoms, molecules, or ions are fixed. In position. While in liquids, from here only the question will come. Liquids, these particles are free to move past one another. They will go by side of it. That is liquid structure is more random and solid structure is ordered. Means they are arranged. A gas has higher entropy than the liquid from which it is formed. When vaporization occurs, the particles acquire greater freedom to move about. See now, understood now why the water evaporation takes place. Evaporation of water takes place because moment it goes to the vapor state, it can move freely in all directions. See, it is I told you that the process which are exothermic, which gives out heat, who reduces potential energy, are spontaneous. But there are various processes which are endothermic. You are supposed to supply heat, but we are not supplying. But still the process is spontaneous. This falls under this category. If the question comes, why evaporation of water, though evaporation of water is endothermic, but still it is spontaneous. So you will write, when the water evaporates, goes to the vapor state, it acquires higher degree of freedom or randomness. Hence, it is spontaneous. So you have to add your own word. I'm explaining everything. I'm not leaving anything. finally you will find that if you increase heat, then you will find the entropy increases. Why? Because solid becomes liquid and liquid becomes vapor. Increasing temperature of a substance the entropy increases. So you find entropy is directly proportional to the temperature around. Then what does it happen? It is because with increase in temperature, see, you try to remember states of matter. With increase in temperature, the kinetic energy of the particles increases, and hence their randomness and the randomness increases. Means what? Randomness is nothing but entropy. They may ask you, why iodine is iodine? Why iodine is soluble in carbon tetrachloride? Just to confuse you, they'll give you this stuff. Or why sugar is soluble in water? So you'll write, sugar molecules in the crystal are tightly packed and have no mobility. When it is being put into water, the iodine crystals break their lattice and goes into water, by which they attain higher degree of freedom. Hence it is soluble in water. Or for iodine, for sugar you will say water, for iodine it is carbon tetrachloride. What happens when a drop of ink is put into a glass of water? You will write, it gradually dissolves. Why? In this process, the molecules present in the ink can move around with a greater degree of freedom. That is, the randomness increases. Hence, it spreads into the entire glass of water. This is the way you have to answer. Everything cannot be discussed in the class. You have to be intelligent to understand. Entropy change in an isolated system. See, isolated system is what? No transfer of heat takes place from surrounding to system. So in an isolated system, heat will increase, and if the heat increases, the entropy loss will increase. In an isolated system, no exchange of matter and energy take place between the system surroundings. So, in an isolated system, involves an increase in randomness due to increase in temperature. Now you can ask me, sir, where from you got this concept of increase in temperature? Because it is a spontaneous process. In spontaneous process, entropy has to increase. Understood now? Therefore, in a spontaneous process, in an isolated system, the change in entropy is positive. Then what could I say? That is, delta S is more than 0. So far, this is an isolated system. Now, what are the systems we have? We have open system. Sorry, we have open system, closed system, isolated system. So isolated system we have already discussed. Now we go for open system and closed system. See, in open system and closed system, what is going to happen? In open system, both the mass and the energy can be exchanged with system to surround surroundings and surrounding to system, just like boiling water in a pan. In open system, what you do, you supply heat, then the water is being heated, and in the process of heating water, water is getting, temperature of the water is increasing. That is the exchange of the energy or the heat takes place, and side by side you will find evaporation of water takes place. Is this what then? System, water is taking the energy from the surroundings, and in exchange what it is giving? In exchange it is giving the water vapor or the matter into the system. This is called open system. In closed system, what will happen? In closed system, water cannot go out of the system, but the heat is being absorbed. So let us go for now open and closed system. So entropy change in open and closed system. See here. Okay. And you have supplied, this is the burner, you find the heat. Clear? Okay, now it's going. So in this case, what is happening? In this case, the heat is absorbed. So it is plus. All right. In that case, if heat is absorbed, then I have to write here minus Q. Why? Because that much heat from outside is being gone inside. And in that case, what is happening? The water vapor is going. Water vapor is going. So what has happened in this case? You find here delta S is positive. Because what is delta S? Delta S is Q by T. And in this case, what is happening? In this case, you will find the heat is decreasing. So as the heat is decreasing, we know heat is directly proportional to the entropy. So the entropy from the outside is decreasing. If it is so, then why does it? If the entropy outside is decreasing, then why should water vapor go? Because when it goes outside, its movement of water molecules becomes so large and enormous. That is, it is much more the loss of the entropy which takes place. All right. So in that case, you'll find when you consider the entropy change of an open and closed system, we have to consider both the entropy of the system and the surroundings. Then only you can find out the total entropy change. See, many places your mother or father may not want that you should go. But sometimes even by telling lies also we go. Why? Because staying in the house, you are under such strict rules. You have hardly expressed your expressions here. When you go outside, you mix with your friends, play and do so much of happiness you get. After coming back also, if you get little scolding, you don't mind. Why? Because the sum total of happiness, from there, if you deduct little bit of unhappiness, still the happiness is more. All right. So in this case, when you consider the entropy change of an open and closed system, we have to consider the total entropy change is nothing but the sum of the entropy change of the system and the surroundings. So I'll write now. The total entropy change in an open or closed system is equal to the sum of entropy change of the system and surroundings. Okay. So I'll write here now. Delta S total equal to delta S system and delta S see. If you add system and surroundings, what you get? Thermodynamically, we call it universe. What we can write? Or delta S universe is equal to delta S system plus delta S surroundings. Okay, now for a spontaneous process, what will happen? For a spontaneous process, I have already told you, in spontaneous process, entropy always has to be more. Okay? For a spontaneous process, delta S total is positive or increases. Therefore, what I can write? Delta S universe equal to delta S system delta S surroundings. When you heat it, positive, no? Greater than 0. Please remember, in universe, everything happening spontaneously. Okay? So entropy of the universe always increases. That is the second law of thermodynamics.
Sir, done.
Okay, now let us go for an isothermal reversible process. Change in an isothermal and reversible process. See, isothermal process is what? Initial and the final temperature is same and is reversible. So in that case, what happened? You have taken the heat from the surroundings. So the entropy has increased in the of the system is increased. Then same amount of heat is being lost from the surroundings. Ultimately, what do you find? The loss and the gain of temperature remains same. So if the entropy of the system increases, entropy of the surrounding, it decreases by the same amount. So if I add, the sum total will be always equal to 0. So right now, yeah. The total entropy change is equal to what? The entropy change in the system plus the entropy change in the surrounding. So let me write here now. If Q amount of heat is absorbed at temperature T by the system, then entropy change of the system, delta S system. See, I can write here plus Q by T. Then again I can write entropy change of the surroundings. Where from you got the heat? From the surroundings. So that much amount of heat you have to subtract. That is, I can write delta S surroundings will be called minus Q by T. Therefore, delta S total is equal to delta S system plus delta S surroundings equal to what? Plus Q by T plus minus Q by T. Therefore, S by T, sorry, Q by T minus Q by T. That is equal to 0. So in a reversible process, it is 0. Isothermal reversible process.
Sir, done.
Okay. Now we'll go for adiabatic process. Entropy change in an, try to remember this term. Huh? What is adiabatic process? No supply of heat. Hmm? So if heat is not supplied, there is no question of change of entropy. So entropy change will be 0. Initial and final will be same. In an adiabatic process, there is no supply of heat. That is Q is equal to 0. Therefore, क्या होगा? Delta S system will be what? Q by T, 0 by T, 0. Similarly, delta S surroundings also will be equal to Q by T, 0 by T will be equal to 0. Therefore, delta S total is equal to, I'll write one more. Delta S system plus delta is equal to
Sir, done.
okay. So I have written thermodynamics as brief as possible. And whatever the statement, the words I have used, I try to make it very simple. Okay. What time your class starts?
Sir, 9.
So today I'll leave you. Then I'm next day I'll take free energy. After free energy, then that portion, thermodynamics portion will be over. Now the question is, my question is that After that, should I go for the, in any of your school, equilibrium chapter started?